Hiya. So in this video, we're going to talk about polar coordinates, which is basically a different coordinate system than what we kind of saw before. So in the previous video, we saw Cartesian coordinates, which basically is saying, okay, this point is here, this point is here, in the exact same way that we've kind of seen in like normal life. But you've probably also potentially seen these things called polar coordinates, right? So polar coordinates is actually defined in the following way. So again, we want to set some origin. So we fix some origin O and an orthonormal basis, right? So we have to have these two. Now what we're going to do is we're going to map so this is in 2 dimensions, right? A2, E2. So we're going to map every tuple. So here we have an R and a theta. We're going to map it to P of 0 plus V, where V has magnitude R. Let me highlight this. V has magnitude R and angle theta with E1. So what does this mean? We mean R has length V, and V inner product with E1 really gives me my length times my cosine, right? Because the length of E1 is 1 because it's an orthonormal basis, so we don't have to add this in. So this R and this theta is what we will use to define the polar coordinates. And so this might be like, okay, whatever. And so what we're going to do is we can actually go back and forth between these two, right? So like this is one way of doing it. And it turns out we can go from one to another. So how do we go from one to another? How do we go from Cartesian to polar, polar to Cartesian? And you've probably seen this before. So x we can consider as r cosine of theta. So here we have xy. So basically what we're doing is we're going from xy to r theta. Now here to kind of remember, this means that we have v is equal to x e1 plus y e2. And this is telling me that the size of v is equal to r. And that the inner product of v with e1 is equal to, basically r cosine of theta, right? So if the inner product of v and e1 is r cosine of theta, this is precisely this this component, right? So this is the same. So that's how we're getting x is equal to r cosine of theta. And through calculations, you can actually find that y is y sine of theta. So you can calculate these. Since we have an orthonormal basis, r is just going to be, well, it's just the inner product, the dot product. So we have x squared plus y squared. And then theta, well, this one's a little more complicated, but in essence, it's just the arctangent of y over x. So if you don't remember what the arctangent is, probably a good time to look it up. Quick little Google search. But yeah, so this is just 2 coordinate systems, and we went from one to another. So there's not one good coordinate system. You can choose many different ones. But because there's multiple options, we're going to choose the easiest. And the easiest is going to be Cartesian for most of the time. And sometimes we'll show, oh, it works for other cases as well. So we'll kind of do that. So basically from now on, we're going to fix some origin O. We're going to fix some orthonormal basis B. And we're going to look at Cartesian coordinates. So this is kind of the big note for the end of this video, in that we're always going to be considering these spaces from now on whenever we're talking about affine spaces. So we'll end this video here, and then we will have one more video, or yeah, probably one more video to kind of end up this week on a little more difficult topic. So I will see you in the next video for something called tangent space.